Hello learners, today I will be discussing on the concept probability. So probability, actually it is a branch in mathematics which measures the likelihood or chance of an event. Probability has a numerical value which ranges from 0 to 1, where 0 indicates the event is impossible. That means it will not occur. 1 indicates that the event will definitely occur. So will occur. 1 will occur. So if I want to define the probability, so where any probable event of, so here I am considering event as A, so probability of event A is number of favorable outcomes by total number of possible outcomes. So here how we are going to interpret, suppose if probability of event A which is equals to 0.5, then the event is equally likely to occur or will not occur. Suppose if probability event A which is greater than 0.5, then the event is more likely to occur than not. So probability of event A, where we say that the event is less likely to occur. So these things you need to keep in your mind before understanding the probability concept. So here when it comes to the calculation of the probability for any event, so we have certain approaches. So classical approach, when we say the classical approach, which is based on the principle that all outcomes of an experiment are equally likely, which assumes that each outcome has the same chance of occurrence. So that's why this particular formula which we can apply to the classical approach, this is actually the classical approach. Say for example, suppose I am rolling a fair six-sided die. The probability of rolling a 3 is, so how much? So I can say event is 3 times. So that will be, probability will be 1 by 6, fair six-sided die. So favorable outcomes for this particular problem will be rolling a 3, definitely there will be 1 outcome, and total possible outcomes will be 6 outcomes. So in the same way we have relative approach, or we can say that empirical probability. Most of the times we use this in the business applications, which calculates based on the observed frequency of an event occurring in a large number of trials, or sometimes by taking the historical data. So here also the probability of event A in the empirical probability which we calculate using considering this as a probability of for event A is equals to number of times event A occurs by total number of trials. Say for example, a manager is observing that in the last 100 days, 30 days had customer complaints. So the probability of a customer complaint on any given day may be considered as P of complaint, that will be how 30. So 30 days by 100 days, so that will be 0.3. See, most of the times empirical probability that we use in the business applications, or sometimes we'll be using in the operations, and we use the empirical ability to make decisions. Sometimes we use this particular empirical probability for predicting or assessing the risk. So if we observe subjective approach, there is another approach, classical approach and empirical probability, and we have other approach of probability, that is subjective approach. So in the subjective approach, basically it is based on the intuition or sometimes opinion, judgment. Instead of taking the historical data and theoretical frameworks, it purely based on the intuition or opinion, or sometimes it may be the judgment. So when to use this subjective? When there is no prior data, or we don't have a particular data set, or if the situation is unique, then we will be using this particular approach. Suppose as I have considered, as here we have three approaches. One is the classical approach, empirical probability or empirical approach, or subjective approach. So if we observe the differences, see slightly differences is there. For example, in classical approach we don't require any data, but in the empirical probability we take the empirical probability we take historical data. But here in the subjective approach, here we don't have data. Sometimes supporting data is also may not be available. So the classical approach, basically it is based on the equality of likely outcomes. Here empirical probability based our approach will be on observed data or experiment. So here what we are taking, personal judgment or intuition or our opinion. So in this way we can differentiate classical approach as well as empirical probability and subjective approach. Now we have, say for example, importance, when it comes to the importance of the probability in business applications, most of the times. So significance of the probability, when it comes to significance, so where we can use maybe to quantify the risks, or why there is a delay in the projects, if any contingency plans are required, then we use this probability for assessing the risk. And sometimes we use probability for forecasting the demand. We can use the like how we can mm, optimize the inventory production, and how we can reduce the cost, how to improve the service. So we can accurately predict using the probability. And also the importance of the probability is there in controlling the quality also, especially in the manufacturing processes. We can estimate whether is there any defect, or whether we are managing the standards, whether we are manufacturing the product as per the standards or not. Is there any deviation that where we can use this particular probability. And sometimes even in the financial decision making also we can use the probability, especially the decisions. We can take the decisions based on pricing of the product, budgeting, or investments to be made on those aspects that we can use. So there are many other importance is there, say for like even in the product development or strategic benefits, supply chain and logistics. We use the probability which improves our decision making as a manager, as we are involved in day to day decision making. So in that particular times, so we may use the probability concepts. So here when it comes to the theoretical theory of the probability, theoretical approaches that we have seen, now here very important. So theory of the probability, in the theory of the probability we have the addition rule. We have the addition rule. So especially when we are having a mutually exclusive event, suppose if two events like A and B are mutually exclusive, then as per the addition rule, if two events cannot occur at the same time. So additional P A union B is equals to P of A plus P of B. Suppose if non-exclusive, this is for mutually exclusive events. Suppose in the case of non-mutually exclusive events are there, then P of A union B is equals to P of A plus P of B minus P of A intersection B, where this is the case of non-mutually exclusive events. So mutually exclusive events, non-mutually exclusive events under the addition theorem of the probability. Suppose by taking some numerical example, if P of A is equal to 0.5, P of B is equals to 0.4 and P of A intersection B is 0.2, then P of A union B will be 0.5, 0.4 minus 0.2, that is equals to 0.7. So here to understand, we have a problem. The problem I am going to, it is already shared, but still again once again I am going through this. What is the problem state? Of 2000 assembled components, 2000 assembled components, 20 have working defect and 30 have structural defect. There is a good reason to assume that no component has both defects. So here we have to find out what is the probability that randomly chosen component will have either type of defect, either type of defect. Suppose, so considering 20, here 20 we have working defect, and 30 we have structural defect. So let we consider events as A and B, the which has working defect and structural defect. So P of A, considering P of A. So working defect. So how much? 20 by 2000. So that becomes 0.01. And P of B. So here 30 have structural defect. So 30 by 2000, that will be 0.015 and 0.5. So here P of A and B, so considered as 0. So chosen component, we have to find out the chosen component which will have either type of defect. That means P either A or B. So A or B. So P of A plus P of B minus P of A and B. So here I am taking 0.01 plus 0.015 minus 0.0, so that becomes 0.025. Now we look at another important aspect, the multiplication rule in the probability. So multiplication rule or multiplication theorem in the probability. Suppose here also we are considering the two events which are independent. So situation A, for independent events, when events are independent, so events considered as A and B, so P of A union B is equals to P of A into P of B. In the same way for dependent events, so we have dependent events. When we look at the dependent events, P of A union B is equals to P of A plus P of B conditional A. So here this one will be considered probability of B given A, probability of B given A. So this is a how to read this probability of B given A. Suppose A, B is there. A given B. Suppose if it is in like this, then A given B. So here let us look at a simple problem. You can refer the so we look at the problem. So the problem here, what is the problem? The odds against a student X solving a business statistic problem are 8 to 6. 8 to 6 and odds in favor of student Y solving the problem 14 to 16. So this I am considering X and Y. So let A will be the event that the first student solves the problem. So second event solved by B. So let us look P of A so 8 to 6. So 6 by 8 plus 6. So that will be 6 by 14. P of B 14 by 14 plus 16. So 14 by 30. So whichever is the least that we have taken here, P of A. So least that we have taken, so we get 6 by 4 and 14 by 30. So here two questions we have. What is the chance that the problem will be solved if they both try independently of each other? So independently with each other. So independent by taking the independently X and Y students. So here, as we have two problems within the problem. So probability that the problem will be solved. Problem will be solved. So that is equals to P. At least one of them solves the problem. Any one of X or Y. So one solves the problem. I am considering this. One solves the problem. That is equal to P A or B. So here X I am considering it as A and Y as B. So P A or B is equals to P of A plus P of B minus P of A and B. So here, as the events are independent, so how I am rewriting this? P of A plus P of B is equal minus P of A into P of B, because here the events are independent. So even the events are independent, so that will be substituting the value 6 by 14 plus 14 by 30 minus 6 by 14 into 14 by 30. So 6 by 14, which you will get 0.43 plus 0.47 minus 0.43 into 0.47, that becomes 0.2209. As in the case of the events which are independent, and the situation is any one of the student will solve the problem. So the probability is 0. That means if we convert into the percentage, multiply with the 100, you will get in terms of the percentage, so that easy to interpret. In the same way, probability that none of them is able to solve. So situation B, no one will solve. Either it may be X or Y. None of them will solve the problem. So here A and B, neither A will not solve, B also will not solve, both will not solve the problem. So which can be written as P of A into P of B. So this also again we can write in the other form. So 1 minus P of A into 1 minus P of B. Okay, 1 minus P of A. P of A is how much? 6 by 14 into 1 minus P of B. P of B is 14 by 30. So 8 by 14. 14 minus 6, 8 by 14 into 30 minus 14. So it will be 16 by 30. Simplifying, you get 0.57 into 0.54, that will be 0.3078. So addition as well as multiplication, and we have conditional probability. Conditional probability. So we look at the conditional probability rule. So conditional probability. So P is given to the B, that is equals to P intersection of B, P of B. So whatever we are calculating, the same thing will get here. So this is a example for conditional probability. So if the probability of being a manager, B is 0.3, and the probability of being a manager and having an MBA, being a manager and having an MBA, so A intersection B is given as 0.2. So we need to calculate P conditional B. So P intersection B, P of B. So 0.2 by 0.3, that will be 0.6666 you will get. So I am simplifying it as 0.67. Conditional probability. This is an example for conditional probability. So these are the things that you need to remember well. Thank you.